Many of us dream of owning a classic car, a prospect only made more exciting if you fix and maintain it yourself. But running a classic car is a very different experience from a modern one. So Andrew Evanson, Senior Operations Manager at Lancaster Insurance, visited Ralph Hosier Engineering Limited to get some beginner's advice from the mechanical maestro himself, Ralph Hosier. He also brought his son Frankie to pass that passion for classics down the generations. Even on simpler classics, there are still electrics to keep an eye on. The two key components are the battery and the charging system. So how do you ensure that they're in good health?
So one of the most common causes of breakdowns is the old 12-volt battery. And that's because they're very often neglected. They've got a certain lifespan, they don't last forever. 5 years is a fairly good innings for a battery, and a lot of it comes down to how well it's charged and how it's looked after. The longer you leave a lead acid battery flat, the worse it becomes. And it's like having a smaller battery, it's got less capacity. So one of the things that we can do to test it is a voltage test. We'll check the voltage on there, and we should see 12 and a bit. Now that bit is quite important. 12.6 is a reasonably well charged battery. 12.8, very well charged. 12.2, that's fairly discharged. 12.0, that's quite a discharged battery. Something's not quite right there. You've either left your car for a very long time, or it's not been charging properly if it's in regular use. So 12.0 would be a problem. So you see that little decimal point makes a big difference. So when you jump start the car, if you're starting it off another vehicle, just allow it to charge that battery up first. So don't try and start the car straight away. The batteries, as I say, they've got a certain life to them. 5 years is fairly good. A lot of the modern batteries have got a little indicator in the top, glowing dot inside it. And this basically tells you how strong the acid is inside it. If it's green, it's fine. If it's red, it needs replacing. The battery is a mixture of sulfuric acid and water, 50-50 mix, and lead plates. And when the battery discharges, the sulfur moves from the sulfuric acid onto the lead plates. And when you charge it up, it knocks the sulfur back into the acid, and it goes backwards and forwards. Discharge goes one way, charge it up, goes the other way. Over time, some of the sulfur sticks onto the lead plates and doesn't come off. And over time, it builds up, and that's what degrades your battery. But it also changes with temperature. So in the winter, it struggles more. The engine's more difficult to start because everything's colder, the oil's colder, there's more viscosity, etc. But also the battery doesn't work quite so well when it's cold either. And in the summer, it eases off a bit. So what you tend to find, as the battery degrades, one winter it's kind of all right, it just about manages, and in the summer it's fine, but actually the battery's carrying on degrading. You just don't notice it because in the summer it has an easier life. And then the next winter happens, now your battery's really degraded, now it has to drive a much more difficult engine because it's cold, and you have all these failures. So the first cold snap we have at the beginning of winter is when everyone's batteries fails. When you pull a lot of current out of it, trying to start the engine, the voltage drops suddenly. As you engage the starter motor, you'll hear the click as the solenoid comes in. That starts pulling a lot of current out of the battery. It engages the starter motor, the voltage collapses right the way down. For any electrical system to work, you need a circuit. So circuit comes from the word circle. So you've got from the positive of the battery all the way around the circuit back into the negative, and the current's got to flow all the way around that loop. If there's any problem on that loop due to poor connections, bit of corrosion on something like that, whether it's on the positive side or the negative side, it'll have the same effect of reducing the amount of current that can flow through that circuit. So as most cars made after the 1950s, the negative terminal of the battery is connected to the bodywork. That connection onto the bodywork's got to be free from corrosion. The terminals themselves have to be clean as well, and tight. The contact pressure is really important. So if the terminal's not done up tight, you'll lose a bit of voltage across it when it starts drawing a big current. To stop corrosion getting in, you can then put a bit of jelly over the top of it, silicon jelly, something like that. After you've started the engine, it's the alternator that provides all of the voltage for the vehicle. The alternator's powering the whole car, and it's also recharging the battery. If you put a heavy electrical load on there, all the lights, the fans on, particularly in winter, you might have the heated screen on and things like that. When the alternator starts wearing out, it can't actually cope with that. And the voltage starts dropping down to the point where it actually starts pulling current out of the battery as well. And then everything starts getting dimmer, and eventually it will start to fail. The alternator has a couple of things on it that wear out. it's got bearings they can wear sometimes, but more likely it's the brushes. These are little contacts that go onto the spinny roundy electrical bits, and they wear down over time. On some alternators, you can actually take the back off and replace the brushes, which is a cheap repair. On some of them, you're encouraged to buy a whole new alternator. To charge up the battery, it's got to produce a voltage higher than the battery voltage. So if the battery is about 12.5 volts, the alternator needs to stick out 13.5, 14.5 volts, something like that, when the engine's running.
So keep close tabs on the voltage that your battery holds, charge it correctly, and don't let it sit for too long. Make sure your alternator is still providing sufficient charge and you've got a healthy electrical system. Illuminating.